row, row your boat gently down the stream. Merrily, 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 life is but a dream. Row, row, row your boat gently down the stream. Merrily, 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 life is but a dream.
Teach you a little something about physics, fluid mechanics, and boats. Have you ever felt so cramped or confined in a crowded area, such as this boat? Well, you probably felt that way because there were too many people in the crowded space for the amount of space available.
In other words, the density of the people was too high.
In general,
mass density.
Mass density is a mass per unit volume of a substance.
Woohoo! Yeah! Have you ever wondered why things feel lighter underwater than they do in air?
The reason is that a fluid exerts an upward force on objects that is partially or completely in it.
This upward force is called a buoyant force. Woo!
Yo, this is because the buoyant force acts in a direction opposite of the force of gravity. The net force acting on an object submerged under the fluid, such as water, is smaller than the object's weight.
Thus, the object appears to weigh less in water than it does in air. The weight of an object immersed in a fluid is the object's apparent weight.
So, have you ever wondered why, when you were playing in your tub, rubby-dub-dub, and you ever had a cup, such as these, and you pushed it down against the water and you're like, whoa, as you push down, it springs back up. And that force is called buoyancy force. So whenever you push something down or anything is placed into the water, there's a force that is pushing up against that object. So as you push it down, water is exerting a force that wants to keep pushing it back up. But there's two forces on this little cup right here. There's a gravitational force, which is pushing down, and the buoyancy force is pushing up. Let's go to the whiteboard to see an example of this. What I've drawn here is the cup in the water right here. There's no liquid or anything in the cup. And then right here, surrounding it is water, obviously. As we saw earlier when we were pushing down on the cup into the water, it sprang back up because there's a force pushing against. This is the net force. And so this arrow going upwards is the buoyancy force. This is the force exerted by the water. And the force pushing down is gravitational force. So these are both very important for why boats or why things either float or sink. There's also another very important reason to why things float, and that is called displacement. When an object is submerged, it will push against these water molecules, displacing these water molecules in certain areas and directions. And going back to the buoyancy force, it will only push up as much with much force as coming down towards it. When we're talking about displacement, we also need to take into account density, the density of this object right here. How much water is displaced is determined by the density of this object right here, so this cup. In the case of a heavy object, such as an egg, its apparent weight is less in water than its actual weight is in air, but it may still sink in water. The buoyant force is not enough to
sinks, the water levels rise. The amount of space the water seems to be taking up is the displaced volume of water. This is equal to the volume of the portion of the egg that is underwater.
Ah! The Titanic. Think of the hole that the iceberg created and where the boat began to sink when the compartments were filled with the water.
Like this. So right here, we have a small diagram of the Titanic and its base. So whenever the Titanic hit the iceberg, there was a huge fall that happened right over here. So because of this hole, all this water started rushing in and started filling up these water compartments. It was designed this way to hopefully be its own lifeboat, essentially. So the whole bottom compartments could fill up and it would still stay afloat until help arrived. But what they didn't think about is the density and displacement. Like we already discussed earlier, when weight isn't equally distributed or displaced, the water doesn't have enough force or push behind it to keep it afloat. So essentially what happened is all these front compartments started to fill up, and that's when the whole boat just went up like this and snapped right in half. So engineers did not think about this.
If an object's density is greater than the fluid density, the net force is negative, or downward, and the object sinks. If an object's the net force is positive, or upward, and the object rises to the surface and floats.
If the densities are the same, then the object hangs, suspended underwater.
Deep sea explorers wear atmospheric diving suits to resist the forces exerted by water in the depths of the ocean.
You experience the effects of similar forces on your ears when you dive to the bottom of your swimming pool, drive up a mountain, or ride in an airplane.
Fluids exert pressure on your eardrums. Pressure is a measure of how much force is applied over a given area.
As the submarine dives into the water, the pressure of the water against the hull of the submarine increases, so the hull must be strong enough to withstand large pressures.
Water pressure increases with depth, because the water at a given depth must support the weight of the water above it.
Mass
Waves.
Have you ever gone canoeing or rafting down a river? If so, you may have noticed paddle along.
At other places in the river, there may have been rocks or dramatic bends that created foamy whitewater rapids.
When a fluid, such as river water, is in motion, the flow can be characterized in one of two ways: laminar or turbulent.
The fluid flow is said to be laminar if every particle that passes a particular point moves along the same smooth path traveled by the particles that passed the point earlier.
The smooth stretches of a river are regions of laminar flow.
In contrast, the flow of the fluid becomes irregular or turbulent above a certain velocity or under conditions that can cause abrupt changes in velocity, such as where there are obstacles or sharp turns in a river.
Irregular motions of fluid, called eddy currents, are the characteristics of turbulent flow.
Many features of fluid motion can be understood by considering the behavior of an ideal fluid, which is a fluid that has no internal friction or viscosity and is incompressible.
A fluid is incompressible if the density of the fluid remains constant.
The term viscosity refers to the amount of internal friction within the fluid. A fluid with high viscosity flows more slowly than a fluid with low viscosity.
As a viscosity fluid flows, parts of kinetic energy of the fluid is transformed into internal energy due to the friction of fluid particles sliding past each other.
Ideal fluids are considered no viscous, so they lose no kinetic energy due to friction as they flow.
Ideal fluids are also characterized by the steady flow. In other words, the velocity, density, and pressure at each point in the fluid are constant.
Ideal flow of an ideal fluid is also non-turbulent, which means that there are no eddy currents in the moving fluid.